parametric equations. And parametric equations are used to express, I can talk a little bit faster than I can write, are used to express the position of an object both horizontally and vertically as a function of time. The variable t is used as the third variable or the parameter. Now, if you'll think about it's not a parameter, it's a parameter. Okay. If you'll think about look at these graphs down here before, what you're used to seeing is time on the x-axis, and you might have vertical distance, or you might have horizontal distance. But when we put it into a set of parametric equations, then we can put the vertical distance on one axis and the horizontal distance on the other axis, and then we can actually see where the object is positioned horizontally and vertically at any time during the path. So, as we go through and do these, all right, one of the things to remember is that when you plot the points of a parametric equation, you always want to plot them in the order of increasing values of t. When you plot them in increasing values of t, it traces the curve in a specific direction called orientation. Okay? And as we set up at the top, the other thing that's important to remember is when you define these parametric equations, they are going to be functions of x. X and y are both functions of t. X is some function of t, and g is, I'm going to erase the whole thing, please. There we go. G is, that would be y is some function of t as well, both of which have to be functions. All right, so we're going to start off with basically sketching with parametric equations. Okay, and what you're going to do when you have these, you have two equations. We have x equals something and y equals something, both in terms of t, and then we're told to go t between 0 and 8. So what I'm going to do is I have a chart here, and I'm going to have t, and I'm going to have x, and I'm going to have y. And I'm going to stop for a minute, and I'm going to go fill in the chart, but all I'm going to do up top, because I don't want you to have to watch all this. Where'd I go? All right, so I'm going to go fill in for t. T is going to go between 0 and 8. 0, 1, 2, 3, 4, 5, 6. And since I don't have enough, I'm going to stop and I'm going to erase that and fix it. But I'm going to go fill in the chart. You try to do the same, and then when you start back up, let's make sure our charts match. Okay, so we have our charts filled in, and I color-coded it so you can see that to get these values that are in purple, I plugged in these values of t into that equation. 0 into that is 0. 1 times 3 is 3, so forth and so on. And then to get the orange, I plugged it into the equation that says y equals. I'm plugging the t values into the equation to get those numbers, those ordered pairs. And now to go plot the points, I'm going to look at my x and y. So I'm going to plot the point 0, 6. 0, 1, 2, 3, 4, 5, 6. And then I'm going to plot 3, 7. 1, 2, 3, 7. And then I'm going to plot 6, 7.4. And then 9, 7.7. 12 is at 8. So you get the idea, and I'm going to go, well, I go past my graph if I go past that, too much farther. 21, this is 20. So at 21, I'm an 8.6, so it's about up there. Okay, so I'm just sketching it with some points, but the important thing to remember is as we connect these, so if I do my best to try to connect them with a curve, this is what it's looking like. Okay, but more importantly, what you need to do whenever you sketch these is you need to draw arrows to show where you started. And we started here, and so this is the direction of the object. And this is telling us at, when x is 3, 1, 2, 3, then y is equal to 7. Okay? So the same thing with 1b. I'm going to go fill in the chart and then I'm going to graph it. But I'm going to pause so that you can try it on your own and come back and then check your work. So I ran out of room by chart again, but I think you have the idea if we needed more points, how we would, just to continue on. And again, I color coded it. Okay, the purple ones, I took the t value and plugged it in to find out what x would be. So all those numbers are the squares. And the pink one is plugging it into this equation to find out the corresponding y value. So in doing so, when we label our graph here, I'm going to label this one. I put 0 in the middle and I'm going to label it by 2's. 0, 2, 4, 6, 8, 12, 16, 20. And this one, every other one, I'm gonna label this one by 5. So we got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so let's go plot our points. I'm gonna use the highlighter again because I'm not gonna have be exact with my numbers most likely. Okay, so as I go here, if I plot when x is 100, then y is negative 17. Actually, yeah, x is 100, y is negative 17. So this is 16, there's negative 17. Let me get that dot better. Okay. Uh, if x is negative, excuse me, at negative 80, or excuse me, 81, I'm at negative 15. So this is 16, so there's negative 15. Um, I'm going to ones that are easy to graph. 64, 49. 49 is right before 50. If I go to 49, I'm at negative 11, which happened to go down. So that was 4, 8, 10, 11. So we're going to be right here. Okay. And then, so I'm just picking, I mean, they asked us to do the chart, so I did the whole chart. 25. 25 is right here, and 25 is negative 7. 4, 6, 7. So we're right there. And what was that, 25? I'm going to go to 9. 9 is at negative 3. So we're here. 1 is at 1. 0 is at 3, which is right here. And then we go back around the other way. So at 9 this time, I'm at 9, which is here. Okay, and then I have 25 is at 13. 12, 13. 49 is at 17. So up to 17 is going to be there. Okay. You get the gist of it, hopefully. So it doesn't matter how you draw your curve. Okay, I'm just going to draw it so that I can kind of connect the dots. But hopefully you can see this is a bit of a... Okay, so I missed my dots. Be nice to me. Actually, I don't want to put that arrow there. Because where did I start? When I started at negative 10, where was my point? My point was 100, negative 17. That means that the direction, the orientation of this object is moving along the path in that direction. So that's the way the arrows should go when you plot your parametric equation. Okay? Now let's go do some math. Um, we have to be able to take rectangular form and take a set of parametric equations and put them in rectangular form. And it's pretty straightforward with what you see. X equals t squared minus 5, y equals 4t. So I'm going to take this equation and I'm going to solve it for t. So t equals y over 4. And then I'm going to go plug it into that equation. And when I do that, I'm going to have x equals y over 4 squared minus 5. So that says x equals y squared over 16 minus 5. And our rectangular equation, we need to solve it to put it in rectangular form, we're going to solve it for y. So I'm going to clear up my fraction by multiplying by 16. 16x equals y squared minus 80. Add my 80. 16x plus 80 equals y squared. I'm going to come on up here. And I'm going to switch because I know most people are comfortable with the y on the other side. So if I take the square root of both sides, then I will have 16x plus 5. So we'll simplify that to y equals 4 square roots of x plus 5. And that is the rectangular form for the parametric equations. Okay? Sometime our domain has to be restricted. So we have to be aware of that. So this time we have x equals the square root of t plus 4, y equals 1 over t. And they want us to put them in rectangular form. Okay? They did ask us to graph the equation, so we may just sketch those. All right, so first off, we do want to look at this, and hopefully you all remember that we cannot take the square root of a negative number. So this thing, t plus 4, has to be greater than or equal to 0. That means t has to be greater than or equal to negative 4. And of course here it tells me t cannot be 0. Okay? But we're going to go do the same thing. If y equals 1 over t, then hopefully y'all can see that t is equal to 1 over y, because we can just cross multiply and divide. And now I'm going to go plug that into the other equation. So when I do that, I'm going to have x equals the square root of, what was t? T is 1 over y plus 4. Okay? To solve that, I have to square both sides. So I square both sides, I get x squared equals 1 over y plus 4. Okay, I'm solving for y, remember? So I got to subtract 4. X squared minus 4 equals 1 over y. Now at this point, it might be easiest for you to think of that as put that over 1 and cross multiply, but you don't have to distribute. X squared minus 4 is equal to 1 because you got to get rid of that again. So y equals 1 over x squared minus 4. And that is the rectangular form of our parametric equations. What kind of restrictions do we have on that domain? Well, remember, this thing itself, the square root, the smallest it will ever be is 0 because we can't take the square root of a negative number, which means x will always be greater than or equal to 0. And from the given function that we have that x cannot be equal to, hopefully I'll recognize what makes that 0, 2. And negative 2 is not in there, so we don't have to worry about that. Okay? Okay, so now we need to graph this thing, and hopefully you remember from our library of functions, y equals x squared. Generally, okay, if I just sketch it out real quick, looks like this. Okay, that's y equals x squared. You're moving it over, and when you're moving it over and figuring out where your asymptotes are, they're at plus or minus 2. But we only have to worry about that's greater than 0. So we have an asymptote at, let's make it this color, at x equal to 2. And then I've got that positive value. And when I add two asymptotes in it, let's go ahead and graph that. What makes that 1? No, it can't be that. Um, we're moving over. I'm just going to sketch it, y'all, so in the interest of time. And then at 0, if I put 0 in here, I would have negative 1/4, so that I know I'm down here, and then I'm just going to sketch it asymptotically. Okay? So that's the general shape. Alright, moving on. Sometimes we have an angle in there, and basically theta and t are interchangeable in our parametric equations. We have x equals 3 times the sine of theta, y equals 8 times the cosine of theta. So, to write that in rectangular form, what we want to do is solve that for the sine of theta. So we're going to have x over 3 equals the sine of theta, and y over 8 equals the cosine of theta. And then if I square, we have our identity that says the sine squared plus cosine squared of theta is equal to 1. So I'm going to plug in my x over 3. X over 3 squared plus y over 8 squared equals 1. And hopefully you can see that's x squared over 9 plus y squared over 64 equal to 1. So we have an ellipse with a center of 0, 0. And from the x, we're going to go over left and right 3 units, up and down 8 units, and do your best to sketch an ellipse. Not so easy. Okay, the last type of problem we have is working with parametric equations, and they're going to give us the rectangular equation. They're telling us the t value, and we're going to go write the corresponding parametric equations that match that rectangular equation. So the first one we have t equal to x plus 1. So I'm going to write up here what our x and y. We're looking for x equal and y equal. Those are going to be our parametric equations, and we're going to write them as a function of t, because that's what we defined at the beginning. So if I take this and solve for x, that of course is just t minus 1, because I'm just taking the 1 to the other side. Now, to figure out what y is, I'm going to go put this in for x into that equation. So that gives me x is equal to t minus 1, and that is 6 minus y squared. So I'm going to subtract my 6. T minus 7 equals negative y squared. Whether you add flip sides, multiply by negative 1, I'm going to have y squared equals 7 minus t. Y equals, now when you solve that, that is plus or minus 7 minus the square root of t. But hopefully you realize that's not a function, okay? Because if I have two different y values for the same x or t, then it's not a function anymore. So when we define it in our parametric equations, we're only going to use the positive. So we're going to have 7 minus t. So these are my parametric equations that, given t equals x plus 1, go along with this rectangular equation. Now, they ask us to graph the equation, indicating the speed and orientation. So I'm going to go quickly. You would set up your little chart. T, x, and y. And I'm going to pause, put the values on there so that you have them, and then we'll come back and graph it together. Okay, so all I did quickly was what I did at the beginning, y'all, is I picked some t values, and I'm picking them, trying to get some whole numbers, but I wanted you to know that they're not always going to be whole numbers. You'll have some decimals in there. But remember that what I want to actually plot are the x and y values. So I'm going to plot these together, and I'm going to plot them with my highlight over here. So I have x equals, if when x is negative 3, y is equal to 3. 1, 2, 3. At negative 1, I have 2.6, a little more than halfway there. At positive 1, I have 2.2. At 2, I have 2. At 5, so that's 2, 3, 4, 5, I have 1. and at 6 I have 0. So, a little bit hard to graph, but you got the idea that, I missed. Y'all know I don't do too well with this, but graphing, stopping there. And remember, in increasing values of t shows you that my orientation is going as such. Okay? Now, they give us another, for part B, they say instead of using t equal to x plus 1, use t equals 3x. So, again, what does x equal? X equals t over 3. Alright, and I'm going to go plug it in, just like I did before. So I'm going to have uh, t over 3 equals 6 minus y squared. So that's going to give me, if I subtract my 6, t over 3 minus 6 equals negative y squared. Just like we did before, y squared equals 6 minus t over 3. And y equals plus or minus the square root of 6 minus t over 3. But I only want the positive, so I'm going to have y equals the square root of 6 minus t over 3. So those are my parametric equations that go along with my rectangular equation there. Again, I'm going to make my table, and I'm going to pause while I go put the values into our equations, okay? And we'll come back together. Remember, when you're doing this, if you have any questions, write them down if I don't get to them, or email me if you have any questions while you're watching this video. Okay, so again, we've got our table, and remember, these values, pick whatever you want, okay, to put in there. Um, and put your values in, figure out what you get for x and y, and then I'm going to plot. So I'm just picking and choosing just like we would any t-chart that we make, okay? I'm going to go plot. Remember that we are plotting this x coordinate with this y coordinate. And I'm going to point something out in a second. So I have negative 1, 2.6. I have 0, 2.4. I have 1, 2.2. I have 2 is 2. I have 2.3. That's a weird one. I don't even know why I want that one. I don't want to plot that one. Then I'm going to go to 2, 3, 4, 5, 1, and 6, 0. Now, one of the things I want you to point out, actually, I'll go ahead and graph this one. So you'll see, trying to connect these dots, but that was pretty bad looking. Again, increasing value, okay, go in the same direction. So they have the same orientation, but notice what t is for this one. They both ended up at this point 60, but this one occurred after 7 seconds, and this one occurred after t equal to 20 seconds. So that's what's telling you that your speed, hopefully you can tell that if it gets there after 7 seconds that it's moving faster. Okay, so for the last one, again, solving for x in that top equation. Um, let's go with t minus 4 is equal to negative 2x. So x equals 4 minus t over 2. When you divide by the negative 2, okay? So that gives me, I'm going to go take that and I'm going to plug it in here. So that's going to give me 4, I'm going to actually split that apart. So let's go with 2, 4 over 2 minus t over 2 equals 6 minus y squared. And I am trying to solve that for y. So I'm going to move my 6 over again. Negative 4 minus t over 2 equals negative y squared. And multiplying everything by negative 1 and switching sides gives me y squared equals 4 plus t over 2, and y equals plus or minus the square root of 4 plus t over 2. So y equals the square root of 4 plus t over 2. Again, making my chart. And I'm going to pause and come back, and then we'll plot that together. I think you know how to plug numbers in. Okay, so we're ready to plot our last one. And notice my points are I chose -8. That was what gave me 6 zeros. So 1, 2, 3, 4, 5, 6, 0. And then I have 5, 1. And then I have 2, 2. And then I have -3, 1, 2, 3, 3. And then I had -10, 4. So interestingly, okay, if I go connect these dots and draw them, you'll see again, each of these is basically the same graph. But what is different, especially about this one versus the first two that we did, is the first point increasing. This is my starting point. So I'm starting here, and now my orientation is different, as you saw as we plotted those points. Okay? But the key thing to remember when you're doing that is the only thing that changes in these graphs, okay? They changed the way we defined our parameter, but our graphs are basically the same, but the speed and the orientation changes. So practice your algebra, get those, plot these points, and come to class with questions ready.